नमस्कार। मैं हूं डॉक्टर राजकुमार जांगड़ा और आज हम करेंगे बेसिस एंड डायमेंशन। बेसिस एंड डायमेंशन हमारे पास चैप्टर है। इसमें सबसे पहले आता है अपने पास लीनियर कॉम्बिनेशन ऑफ वेक्टर्स। लीनियर कॉम्बिनेशन ऑफ वेक्टर्स। ए वेक्टर V belongs to VF. This VF is a vector space. Capital VF is a vector space is said to be a linear combination of vectors v1 v2 up to vn belongs to capital V if V can be expressed as a1 v1 plus a2 v2 up to an vn where ai's are scalars. ai's are scalars. Then this small v, this is linear combination of these vectors v1 v2 and vn. Next we have linear combination, linearly independent and linearly dependent. Linearly dependent of vectors. A set of vectors v1 v2 up to vn. This is linearly independent if there exist scalars a1 a2 up to an such that a1 v1 a2 v2 plus up to an vn equal to 0 implies all ai's are 0. Then these vectors v1 v2 vn are said to be linearly independent. These vectors are linearly independent if at least one ai is not equal to 0, then these vectors v1 v2 up to vn are said to be linearly dependent. That is, linear combination equal to implies all scalars are 0. Then this is Li, and linear combination equal to 0 implies at least one scalar. This is non-zero. Then we say that set of vectors are linearly dependent. Next we have another result. Every subset of a every subset of a linearly independent set is linearly independent. Proof. Let S1, this is V1 V2 up to Vn, this is linearly independent, and let S2, this is equal to v1 v2 up to vr, where this r is less than n, be a subset of S1. Then we shall prove that this S2 is also linearly independent. This is also linearly independent. For this, let there exist scalars a1, a2 up to ar such that a1 v1 plus up to ar vr is equal to 0. This can be written as a1 v1 up to ar vr plus में 0 vr plus 1 up to 0 into vn, this is equal to 0. This is linear combination of v1 v2 up to vn n vectors equal to 0. Linear combination of these vectors equal to 0, but these vectors are linearly independent, therefore all scalars must be equal to 0. That is a1, a2 up to ar. All scalars are equal to 0. So this S2 is also linearly independent. Hence, subset of a linearly independent set is linearly independent. Next result is every superset of a linearly dependent set is linearly dependent. Proof of this result: let S1 is equal to V1 V2 up to Vr. This be a linearly dependent set, and let S2 is equal to V1 V2 up to Vn, where R is strictly less than n. Then we shall prove that this S2 is also linearly dependent. Since S1 is linearly dependent, therefore there exist scalars not all 0. That is, there exist AIs not all 0, but such that A1 V1 plus A2 V2 up to AR VR is equal to 0. Now we can write this as A1 V1 up to AR VR plus 0 VR plus 1 up to 0 into Vn equal to 0. यहाँ v1 v2 vr r वेक्टर्स का लीनियर कॉम्बिनेशन 0 है, और जो स्केलर्स है a1 a2 ar, AIs are not all 0. That is, at least one scalar must be non-zero. Next, we have this is a linear combination of n vectors equal to 0, but at least one scalar a1, a2, ar is non-zero. So this set of vectors S2, this is also linearly dependent set. Hence, superset of a linearly dependent set is again linearly dependent. Next result, a set which contains the null vector 0. This is always linearly dependent. Similarly, next result is a set of vectors v1, v2 up to vn is linearly independent, then none of vi's is 0. अब ये n वेक्टर्स हैं, ये लीनियरली इंडिपेंडेंट है, तो कोई भी वेक्टर इसमें जीरो नहीं होगा. एनी सिंगल वेक्टर अगर इसमें जीरो आ जाए तो ये सेट ऑफ वेक्टर्स हैं, ये क्या होगा हमारे पास लीनियरली डिपेंडेंट. अब हमारे पास हैं कुछ एग्जांपल्स हैं. सम एग्जांपल्स प्रूव करते हैं हम. Examples of linear combination of vectors. First example is u is equal to 2 minus 5 and 4. This is a linear combination of v is equal to 1 minus 3 and 2 and w is equal to 2 minus 1 1 or not. अब यहाँ हमें चेक करना है u इन v और w वेक्टर्स का लीनियर कॉम्बिनेशन है या नहीं है. तो उसके लिए हम चेक करेंगे. देखो, u इज इक्वल टू a v प्लस b b w. u is 2 minus 5 and 4. a into v is equal to 1 minus 3 and 2 plus b into 2 minus 1 and 1. This is equal to a plus 2b minus 3a minus b 2a plus b. Now comparing these elements. Therefore we have a plus 2b, this is equal to 2, minus 3a minus b, this is equal to minus 5, 2a plus b is equal to 4. अब यहाँ हम सेकंड और थर्ड इक्वेशन को सोल्व करते हैं और उनसे वैल्यूज फाइंड आउट करेंगे a एंड b की. इफ a एंड b satisfy this first equation, then we can write u as a linear combination of v and w. So second और थर्ड इक्वेशन को सोल्व करते हैं. 2a plus b is equal to 4 minus 3a minus b is equal to minus 5. b से b कैंसिल. माइनस a इज इक्वल टू माइनस 1, a इज इक्वल टू 1. अब इस a इज इक्वल टू 1 को थर्ड इक्वेशन में पुट करते हैं. b इज इक्वल टू 4 माइनस 2, दिस इज 2. अब हमें चेक करना है a1 b2 इस फर्स्ट इक्वेशन को सेटिस्फाई करता है, यानी 1 प्लस 2 इंटू 2 दिस इज इक्वल टू 2. 1 plus 2 into 2, this is 4 is equal to 2. 5 is equal to 2, this is a contradiction. Therefore, u cannot be written as a linear combination of v and w. Next we have another example. Next example is, can the polynomial 3x square minus 5x plus 7 a linear combination of two polynomials, that is, let a into first polynomial is 2x square plus 7x minus 3 plus b into next polynomial is x square plus 3x minus 5। अब हमें चेक करना है ये पोलिनोमियल जो है वो इन दोनों के लीनियर कॉम्बिनेशन में है या नहीं। तो उसके लिए हम ए और बी स्केलर्स लेते हैं। फर्स्ट पोलिनोमियल को ए से, सेकंड को बी से मल्टीप्लाई करके ऐड करेंगे, ये पोलिनोमियल लिखते हैं। नाउ मल्टीप्लाई दिस 2ax square plus 7ax minus 3a plus bx square plus 3bx minus के 5b, taking x square common, this is 2a plus b, taking x common, this is 7a plus 3b, and constant term is minus 3a minus 5b. Now comparing the coefficients of like powers, 2a plus b, this is coefficient of x square and this is equal to 3, and 7a plus 3b, this is equal to minus 5, minus 3a minus 5b, this is constant term which is equal to 7। तो अब यहाँ पे फर्स्ट और सेकंड पोलिनोमियल को सोल्व करते हैं, ए और बी की वैल्यूज फाइंड आउट करेंगे, ये थर्ड को सेटिस्फाई करेगी तब तो ये लीनियर कॉम्बिनेशन में लिख सकते हैं, अदरवाइज हम इसको नहीं लिख सकते। तो इसको मल्टीप्लाई करते हैं 3 से और इसके अपोन में लिखेंगे दिस इज 6a plus 3b, this is equal to 9, and subtracting this, cancel 3b 3b, a is equal to minus 14। अब 2 into minus 14 plus b is equal to 3, therefore b is equal to, this is minus 28 plus 28, this is 31। Putting these values in third equation, this is plus 42, this is minus k, 155 is equal to 7, this is minus k, 113 is equal to 7, not possible. Hence this polynomial cannot be written as a linear combination of these two polynomials. Next example is, find the condition on ABC such that the matrix A minus B, B and C is a linear combination of 1 1 0 minus 1, 1 1 minus 1 and 0, and 1 minus 1 0। हमें कंडीशन फाइंड आउट करनी है ABC पे जब ये मैट्रिक्स इन 3 मैट्रिसेस का क्या है, लीनियर कॉम्बिनेशन। तो आप लिखोगे A माइनस B B C इज इक्वल टू A1 इंटू 1 1 0 माइनस 1 प्लस A2 इंटू 1 1 माइनस 1 एंड 0 प्लस A3 इंटू 1 minus 1 0 0। This is A1 plus A2 plus A3. Next is A1 plus A2 minus A3. This is minus A2. This is minus A1. Comparing these matrices, then minus A1 is equal to C, that is A1 is equal to minus. Minus A2 is equal to B, therefore A2 is equal to minus B. And A1 plus A2 plus A3, this is equal to A. Putting values of A1 is minus C, A2 is minus B plus A3. This is equal to A, hence A3 is equal to A plus B plus C. Therefore, we have A1, A2 and A3. For finding the condition on ABC, this fourth element A1 plus A2 minus A3, this is equal to minus B. Then A1, A2, A3 must satisfy this equation. Putting values of A1 is minus C, A2 is minus B, this is plus A plus B plus C is equal to minus B. B से B कैंसिल, और यहाँ देखो C से C कैंसिल, minus A is equal to minus B, therefore A minus B is equal to 0. This is required condition. देखो यहाँ कहाँ प्रॉब्लम हो गई इसमें, ओ यहाँ प्रॉब्लम हो चुकी है बाय मिस्टेक. इसको अब हम अगेन पुटिंग वैल्यूज ऑफ दिस, कंडीशन फाइंड आउट करने के लिए यहाँ वैल्यू पुट कर लेंगे. इसमें A1 की वैल्यू है माइनस सी, माइनस बी माइनस A प्लस बी प्लस सी इज इक्वल टू माइनस बी, माइनस सी माइनस बी माइनस ए माइनस बी माइनस सी, दिस इज इक्वल टू माइनस बी से माइनस बी कैंसिल होगा, तो आपके पास आता है माइनस ए माइनस बी माइनस 2c इज इक्वल टू 0. माइनस से मल्टीप्लाई करेंगे तो a प्लस बी प्लस 2c इज इक्वल टू 0. दिस इज रिक्वायर्ड कंडीशन. Next we have another example. Determine whether set of vectors 1 minus 2 1 2 1 minus 1 7 minus 4 and 1, these are linearly independent or dependent. For this we have some results. If Ax is equal to B, system of linear non-homogeneous equations, then first we find determinant of A. either determinant of A not equal to 0 or determinant of A 0. If determinant of A not equal to 0, then we have unique solution x is equal to A inverse into B. If determinant 0, then we find adjoint of A into B. Then again two possibilities, either this is not equal to 0 or this is equal to 0. If this is not equal to 0, then we have no solution. If this is equal to 0, then we have infinite many solutions. Similarly, in case of homogeneous system of linear equations, Ax is equal to 0, we have determinant of A. Either determinant of A not equal to 0 or determinant of A 0. If determinant of A 0, then we have unique solution x is equal to A inverse into B. Here B is equal to 0, then x must be equal to 0, that is 0 0 solution, then linearly independent. If determinant of A equal to 0, then we find adjoint A into B. Here B is equal to 0, so adjoint A into 0 is again 0, then we have non-zero solution, so this is case of linearly dependent of vectors. Linearly dependent of vectors. तो अब हम इसके लिए चेक करेंगे ये थ्री वेक्टर्स हमारे लीनियरली इंडिपेंडेंट हैं या नहीं। तो उसके लिए हम इसको लिखेंगे a इंटू 1 माइनस 2 1 प्लस b इंटू 2 1 माइनस 1 प्लस c इंटू 7 माइनस 4 1 is equal to 0. So we have a plus 2b plus 7c is equal to 0 minus 2a plus b minus 4c is equal to 0. A minus b plus c, this is equal to 0. This is of the form Ax is equal to 0, where A is equal to 1 2 7 minus 2 1 minus 4 1 minus 1 and 1. First we find determinant of A. Determinant of A, this is equal to 1 into this cross 1 minus 4, this is minus 3 minus 2 into this minus 2 plus 4, this is 2 plus 7, this cross 2 minus 1, this is equal to 1 minus 3 minus 4 plus 7, determinant is equal to 0. Therefore these three vectors are linearly dependent. We have non-zero solution. Similarly, we can prove some examples. Vectors are linearly dependent or not. Now we have another formula for finding vectors are linearly dependent or linearly independent. For this, we use method of rank of matrices. A augmented B matrix or matrix A. In case of A augmented B, result is if rank of A is equal to rank of A augmented B is equal to number of unknowns, then we have unique solution. Unique solution. If rank of A, this is not equal to rank of A augmented B, then this is no solution case. Third one is if rank of A is equal to rank of A augmented B. This is less than number of unknowns. Then we have infinite many solutions. Now we have homogeneous case. In homogeneous case, if rank of A is equal to number of unknowns, then linearly independent. Second one is if rank of A is less than number of unknowns, then this is linearly dependent. Next we have some examples. 1 0 minus 1 minus 1 0 0 1 0 1 2 1 3. Check these vectors are linearly independent or dependent. For this, let 1 0 minus 1 plus b into minus 1 0 0 plus c into 1 0 1 plus d into 2 1 3. This is equal to 0. This is a minus b plus c plus 2d is equal to 0. D is equal to 0 minus a plus c plus 3d is equal to 0. अब इसको सिंपल मेथड से भी सोल्व कर सकते हैं हम. Here d is equal to 0. Putting d is equal to 0 in this, तो minus a plus c is equal to 0. Therefore a is equal to c. Putting a is equal to c and d is equal to 0 in this equation. So c minus b plus c plus 0 is equal to 0. Therefore b is equal to 2c. If we put c is equal to 1, then b is equal to 2, a is equal to 1, d is equal to 0. This is non-zero solution. So these four vectors are linearly dependent. Similarly, we can prove other examples. Next example is if three vectors a 0 1 are linearly dependent, then find the value of a. If these vectors, three vectors are linearly dependent, so there exist scalars. Not all 0, but their linear combination must be equal to 0. So there exist a1, a2, a3 such that a1 into 1 minus 1 3 plus a2 into 1 2 minus 3 plus a3 into a0 1 is equal to 0. This can be written as a1 plus a2 plus a into a3 is equal to 0 minus a1 plus 2a2, this is equal to 0. 3a1 minus 3a2 plus a3 is equal to 0. This is of the type ax is equal to 0, where a is equal to 1 1 a minus 1 2 0 3 minus 3 and 1. If these three vectors are linearly dependent, then their determinant must be equal to 0. Therefore 1 into 2 minus 1 into minus 1 plus a into 3 minus 6, this is minus 3 is equal to 0. 2 plus 1 minus 3a is equal to 0. Therefore 3 is equal to 3a, hence a is equal to 1. So we can find easily the values of this scalar constant a. So we can find vectors are linearly independent और डिपेंडेंट. तो आज हमने क्या सीखा था इसमें लीनियर कॉम्बिनेशन ऑफ वेक्टर्स, दूसरा लीनियरली डिपेंडेंट ऑफ वेक्टर्स, लीनियरली इंडिपेंडेंट ऑफ वेक्टर्स. तो लीनियरली इंडिपेंडेंट कब है? इफ लीनियर कॉम्बिनेशन ऑफ वेक्टर्स इक्वल टू 0 implies all scalars equal to 0, then this is linearly independent. Linearly dependent कब होगा? If linear combination equal to 0 implies at least one scalar not equal to 0, then this is linearly dependent. और कुछ हमने theorems की है, जैसे कि subset of a linearly independent set is linearly independent and superset of a linearly dependent set is again linearly dependent. A set containing 0 vector, this is linearly dependent, and a set is linearly independent, then none of the vectors is 0. So आज हम इसमें ये जो है लीनियर कॉम्बिनेशन, linearly independent, linearly dependent